Alright, so now that you know how to do integration and even U substitution, let's talk about some special functions having to do with natural log and logarithms. And the first thing I should remind you of is the derivative of the natural log of x, because this is going to be how we work backwards to do an integral, right? So the derivative of natural log, hopefully you still remember that it is equal to 1 over x. And so what we're going to be working on now is the opposite, right? So, I mean, if I gave you the integral of 1 over x, then naturally you can assume that it's going to be the natural log of x. Now, I'm forgetting the plus c. There's also one other thing that's a little different that I'm forgetting. There needs to be absolute value signs around your answer whenever you're doing an integral, and don't get too caught up on it. It's sort of notation, because we know that you cannot take a log of a negative number, so we're sort of forcing this to be a positive x, and that's the only values that we're going to be able to answer with. So just don't forget that you will need that absolute value sign. Okay, so if this is the most basic of truths, then what if it gets more complicated, right? So in other words, what if I'm trying to take the integral of something like 3 over 2x plus 6 dx. And so whenever you have something like this and you notice that there is a function within the denominator, you are probably going to have to do a u substitution. And whenever this happens, usually the u substitution, or what you let equal u, is the denominator. So what I'm going to do is I'm going to try this and see if this turns into something that's similar to what we have right here. So if u is the denominator, then that would mean that the du is 2 dx. And remember, at this point, you know, we get to start recopying this and replacing what we have with our u stuff. So there's this 3 on top still, the denominator's a u, and the dx I'm going to replace with a 1/2 du. So you just kind of rearrange this so that you can replace this one with a du instead. So I like to put my 1/2 in the front. Anytime I move a constant over, I always stick it in the front. Your teacher probably does something similar. Now, if that 3 is throwing you and you're like, oh my gosh, what'd I do with the 3? Okay, guess what? Feel free to suck that out also. So in other words, it can be 3 there and a 1 right there. So by doing this, this makes it a pretty easy problem, because now the integral of 1 over u would just be the natural log of u. Of course, we have a plus c because this is an indefinite integral, and your last step should always be to plug your u back in. And that's how you are going to take an integral of something like this. So hopefully that makes sense and it at least gets you started. The only other type I want to do in this video is a base other than e. So instead of natural logs, the question becomes like, okay, what if we're dealing with logs instead? And this is something that you probably haven't done before at all. And you probably don't even know the derivative of this. So if it's not a natural log, it sort of works out the same, but there's one little difference. So it's similar to natural log in that it starts out as 1 over x, okay? Kind of like natural log of x is 1 over x. But because it's a different base, we actually need a natural log of whatever that base is. And there's a whole reason behind it, and you could prove it pretty easily, but this video is not about proving it, it's just about doing it. So this would be how you do a derivative if it's not a natural log. Also, while we're on this subject, we all know, hopefully, that the derivative of e to the x is just e to the x. But what if I change that to something else to the x, like maybe 2 to the x, 3 to the x, whatever? Well, this is similar to the one up here. What's going to happen is it is going to be itself. However, since it's a base other than e, we're going to have this added multiplier of natural log of a on the front. So notice it's just adding that extra little piece of ln a. And if you have to do something like this, I mean, just as an example, these aren't too bad. Like I could do the derivative of, let's say it's like 3 to the x squared. So if I had to do this, I would start with just thinking of it as 3 to the x, and I would break into that formula. So it would be the natural log of 3 times 3 to the x squared, but then I would have to do a chain rule on that exponent and put that at the back. So hopefully that kind of all rings a bell, but that's how that's going to work. Now, this one and this one, all of these should be memorized at some point. And now let's talk about the integrals of those same things. I'll switch to a different color. So it becomes, you know, how do we do this? Or how do we do this? Okay. And actually, I'm going to go ahead and cross off this one because guess what? You're not going to have a formula that's just going to make that, you know, doable and easy in one fell swoop, and it's not something you'll need to memorize. So let's just focus on this one. It's going to be similar to taking the derivative of it. However, you also have this natural log coefficient, but now it's going to be 1 over the natural log of a. And that's going to be how you deal with something like that. So let's do one example of that. So for instance, if we're just going to do a basic one to start with, what if I wanted the integral of 2 to the 3x dx, okay? If I want to do this, the first thing is to notice it's not just an x in the exponent, so technically you are going to do a u substitution for that exponent. So u is 3x, and du would equal 3 dx. Now there's no other 3 in the problem, so I'm going to bring that 3 over as a 1/3. And the reason I'm doing that is so I can simplify this and make it 1/3 out front, 2 to the u du. Now I can look up here and use this rule, okay? So I'm going to recopy the 1/3. The antiderivative of 2 to the u is going to be 1 over the natural log of 2 times 2 to the u. And as your last step, remember you always want to go back in and plug in whatever your u is. And all I'm going to do is clean this up a little. I'm going to call it 1 over 3 ln 2. I'm just putting those together. Times 2 to the 3x plus c. And that would be how you could answer this problem. So hopefully that's enough to get you started with funky derivatives of logs, natural logs, e, and everything's going to be either a chain rule or a u substitution, most of it anyways, depending on whether you're doing a derivative, that would be the chain rule, or an integral, that would be the u substitution. All right, hopefully that helps.